Right now, the US tech job market is going through a massive structural shift. Look, if you're eyeing 2026 and wondering if the window for tech has somehow closed, you're looking at the wrong data. In this explainer, we're going to break down exactly what the modern software engineering roadmap looks like today, and we're starting right at ground zero, the landscape itself. No fluff, just the concrete reality of what the market is doing right now and where the money is actually flowing. All right, let's just dive straight in.
15%. Seriously, take a second to just let that sink in. Because when you're talking about the massive US labor market, a double-digit growth figure like this is absolutely staggering. And hey, this isn't some wild guess from a random tech blog. This is the exact official projected growth rate for software developers straight from the Bureau of Labor Statistics.
And check out the time frame here, 2024 to 2034. That 15% growth over the next decade, that represents a massive macroeconomic boom. It completely validates why you're focusing on this field right now. Look, while other industries are facing stagnation or even contraction, the demand for people who can build, scale, and maintain complex digital infrastructure in the US is literally accelerating. This is a prime, long-term opportunity for aspiring engineers. The jobs are going to be there. But to actually capture those jobs in 2026, well, we have to clear up a massive roadblock that trips up almost everyone entering the field.
All right, part one, engineer, developer, or programmer.
You constantly hear words like engineer, developer, and programmer thrown around interchangeably, right? But honestly, treating them as the exact same thing will absolutely cap your career. On one side, we have the programmer. The focus here is pretty straightforward, writing code. It's about making a single script work or, figuring out why a button refuses to turn blue despite your absolute best efforts. Now contrast that with the software engineer on the other side. The focus completely shifts. Yes, they write code, but their primary focus is on reliability, scalability, and system design. A programmer asks, okay, how do I make this feature work? But a software engineer asks, how do I make this feature work for 10 million simultaneous users without crashing our servers, all while ensuring the code is actually maintainable for the next 5 years? It's a completely different mindset. It's literally the difference between laying a single brick and architecting an entire skyscraper.
So the absolutely crucial point here is that term right at the end, system design. That concept is exactly what separates high-level engineers from those who just write code. System design is the process of defining the architecture, the components, modules, interfaces, and data for a system to satisfy specific requirements. Because here's the reality in 2026. Companies are not just paying for lines of code anymore. AI can write lines of code. Companies are paying for the human ability to design robust systems. They're paying for your ability to see how a database interacts with the server, how the application scales during a massive traffic spike, and how secure the entire pipeline is from end to end. Mastering this architectural mindset, that is your true entry ticket to the big leagues.
Which brings us to part two, the specialization salary premium. Okay, let's hit the brakes on the theory for a second and get ruthlessly practical. Picking a lane is no longer optional. Generalists get left behind. In the past, you could totally get by being a jack of all trades, master of none in the tech world. You knew a little front end, a little back end, maybe how to spin up a server, and hey, that was enough for a really comfortable career. But not anymore. The tech landscape has matured and it's complexified to a point where deep expertise is demanded. If you remain a pure generalist in 2026, you are competing in an incredibly saturated pool. The real financial rewards, the life-changing compensation packages, they are reserved exclusively for those who specialize. Let me show you exactly what this looks like in dollars and cents.
Down at the baseline, we have full stack. Now, don't get me wrong, full stack is an incredibly solid foundation. You're looking at a median US salary of around $140,000. It's a fantastic living, and it proves you have a comprehensive understanding of both the front end and back end. But notice what happens when you pick a highly specialized lane, something like DevOps or Site Reliability Engineering, SRE for short. That median salary leaps to between $140,000 and $180,000. Why? Because these are the engineers responsible for keeping the entire company online. When a service goes down, the company is literally losing millions by the minute. DevOps and SRE specialists engineer the deployment pipelines and the infrastructure reliability that prevents those massive catastrophes from happening. Companies will happily pay that premium for peace of mind and operational stability.
Now, before we get to the absolute peak of the compensation mountain, we definitely have to acknowledge back-end and data engineering. These are critical, high-demand technical lanes right alongside DevOps and full stack. Think about it. Data is the lifeblood of every modern enterprise. And data engineers, the people who build the pipelines to process terabytes of information, they are fiercely sought after right now. Similarly, deep backend specialists who design complex logic and database interactions, they are foundational to any tech product. Picking either of these lanes secures a highly lucrative and incredibly stable career path. But if we're talking about the absolute ceiling of the current market,
20 to 56%. And listen, this isn't the base salary we're talking about here. This is the premium. This is the extra percentage companies are paying on top of those already massive baseline engineering salaries we just talked about.
This is the ML and AI engineering premium. Machine learning and artificial intelligence specialists are currently securing a 20 to 56% premium over standard engineering roles. Why is it so high? Because we are right in the middle of a generational shift in technology. Every Fortune 500 company, every startup, every legacy institution in the US is desperately trying to integrate AI into their products. But they're hitting a massive bottleneck. There simply aren't enough engineers who actually understand how to train, deploy, and scale machine learning models in real-world production environments. If you specialize here, you're not just an employee anymore. You are arguably the rarest asset on the market.
So, synthesizing this whole macro to micro financial funnel, you can really see the trajectory here. You start with a great baseline at full stack, sitting around 140K. Then, as you specialize into infrastructure with DevOps and SRA, you push that average up to 160K and beyond. But when you move into the bleeding edge of ML and AI, you see that massive spike, up to 56% higher. This shows you exactly how picking a specific high-value lane maximizes your earning potential in the 2026 landscape. It's not just about working harder, it's about positioning yourself in the areas of highest demand and lowest supply. But of course, there's a catch. You can't just jump straight to AI or DevOps. You have to build the house before you can put the roof on.
So the 2026 playbook is pretty clear. Master system design to become a true engineer, and then specialize in high-leverage areas like cloud or AI to command top-tier compensation. But here's the ultimate question. If you're aiming for the top of that mountain, is your baseline strong enough to actually support the climb? Are you really ready for the core foundation? Well, in Part 2, we're going to break down the exact foundational skills every single path demands before you even think about specializing. I'll see you there.
Welcome back to The Explainer. If you caught Part 1, you already know the 2026 job market is wild, and we looked at those massive specialization premiums waiting for developers who reach the top of their game. But today, we're stripping all of that away. We're looking at the absolute, non-negotiable core foundation every single developer in the US has to build first. Because before you can command those top-tier salaries or claim a flashy title, you've got to pour the concrete. So let's build it together. Here's our roadmap for today. We'll start with the 2026 engineering landscape, move into building the core foundation, explain why this exact order matters, dive into AI's real job impact, to find the new junior developer, and finally look at choosing your specialization next. Let's kick things off with Section 1, the 2026 engineering landscape. There's a really stark contrast we need to talk about right out of the gate. The ultimate goal for most of us is hitting those high-paying specialization tiers, but the mandatory prerequisite to get there is this core foundation. You absolutely cannot unlock the lucrative stuff without mastering this unskippable base first. Honestly, employers aren't looking for people who can just run quick scripts anymore. They need professionals with a rock-solid base. If you skip the foundation, you're never going to reach the specialization. It really is that simple. Moving right along to Section 2, building the core foundation. So here are your 5 mandatory steps. You're going to start with a core language, usually Python or JavaScript. Step 2 is data structures and algorithms. Step 3 is Git and version control. Step 4 covers databases, and Step 5 is basic system design. Think of these first 3 steps as literally pouring the concrete of your entire career. Python and JavaScript are your heavy hitters. They give you the core logic without bogging you down in crazy memory management. Then, data structures and algorithms step in to train your brain in problem solving. This is about making a program run efficiently instead of, totally crashing the server. Next up is Git. Think of Git as your safety net. It's collaboration and version control so you can work with 50 other devs without accidentally deleting the company's production code. We've all been there, and trust me, you don't want to be that person. Then we round out the foundation with the last 2 steps. Databases are totally essential for managing information. I mean, an application is pretty useless if it forgets everything the second a user logs off, right? So secure data storage is a must. Finally, basic system design is the capstone. It connects the pieces. It teaches you how the front end actually talks to that database and what happens when 1,000 users log in at the exact same time. It's the blueprint of the whole machine. Which brings us to Section 3, why this exact order? You might be wondering why you have to learn these skills in this specific chronological order. Well, it's exactly like constructing a physical building. You simply can't pick out the interior design or your advanced specialization before the foundation is poured and cured. If you try to jump into databases before knowing a programming language, you literally can't write the logic to access your data. Or if you try system design without knowing data structures, your system is going to be unbelievably slow. Every single step on this roadmap relies heavily on the one right before it. It's not arbitrary, it is the proven progression of computational thinking. But wait, stop right there. We need a massive reality check because everything we just talked about, you absolutely still need to know it, but the way you actually use it has changed forever. The traditional junior coding job, the one where you just sit in a cubicle typing out basic loops all day, is entirely gone. AI tools now write the boilerplate code for you. This is the biggest pattern interrupt the tech industry has seen in decades, and it completely rewrites the rules for your career. Let's unpack that in Section 4, AI's real job impact. The divide here is super clear. 5 years ago, the old junior dev was basically a human typewriter, getting paid to produce raw, repetitive boilerplate code. But the 2026 junior dev is a director. The AI is the human typewriter now, spitting out hundreds of lines of syntax in milliseconds. Your job is to be the editor, the auditor, and the strategist reviewing and directing that AI-written code. And that leads us to Section 5, the new junior developer. Because of this shift, your ultimate survival skill today is what we call system-level thinking. This is the ability to understand how different components of a software system interact. It's essential for reviewing and directing AI code rather than just producing it yourself. AI doesn't know your company's unique business logic, but with system-level thinking, you can zoom out, spot disastrous structural flaws in the AI's output, and make sure all the pieces connect safely. So your new day-to-day looks totally different. You'll spend way less time writing basic syntax and a lot more time reviewing AI output. You're the one finding those invisible edge cases and security vulnerabilities. Your main focus is ensuring architectural integrity. You give the AI the macro problem, and then you assemble its micro solutions into a real product. This is exactly why that core foundation we talked about earlier is so crucial. You simply cannot correct an AI if you don't deeply understand the foundations of software yourself. Finally, Section 6, choosing your specialization next. Now that your foundation is rock solid and you know how to navigate the AI era, you're ready for the next step. Make sure you join me in Part 3 of this Explainer series, where we'll cover the 4 highest paying specialization tracks in the US market right now and exactly how you should choose between them. We'll look at the specific premiums they command and how to bridge the gap from your new core foundation straight into a highly specialized career. Until then, ask yourself, are you ready to stop just typing code and start architecting the future? See you in the next one.